Open a new model in Abaqus. Rename it Sandwich Structure. Create a new part named Top Layer, which is a 3D deformable solid extrusion. Set the approximate size to 2. Use the Create Lines Rectangle tool and the Add Dimension tool to sketch the part. Create another part called Core Layer, which is also a 3D deformable solid. Once again, use the Create Lines Rectangle tool and the Add Dimension tool to sketch the part. We shall use the Create Cut Extrude tool to cut rectangular holes and create the core cells. Abaqus prompts you to select a plane for the extruded cut. Select the top surface of the core. You are then asked to select an edge or axis that will appear vertical and on the right. Choose the appropriate edge to proceed. You will find yourself in the sketcher. Use the Create Lines Rectangle tool to draw 6 rectangles. Dimension the first one using the Add Dimensions tool. Click the Add Constraint tool. We will use the equal length constraint to make the lengths and widths of all holes equal. Set the distance from the top edge of the first hole to the top edge of the core layer to be the wall thickness, or 0.04 meters. We can then use a coincident constraint to make all the corresponding edges of the holes line up with each other. Set the distance from the other edge of the first cell to the edge of the core layer to be 0.4 meters. Set the wall thickness between each cell to match this as well. Now that the section for the extruded cut has been sketched, click Done. Ensure that the extrusion arrow points into the core layer, otherwise click the Flip button. Set the extrusion type to Through All. The cut extrusions are created and our core layer is ready. While the core layer is exactly as we need it to be, we could have constructed it more easily using patterns. Let's demonstrate that while we've got the opportunity. We'll delete the current cut extrusion and rebuild it with a pattern. Expand Core Layer in the model tree and expand the Features container. Right-click Cut Extrude 1 and delete it. Once again, choose the Create Cut Extrude tool and follow the same procedure as before to reach the sketcher. Sketch and dimension the first rectangle. Also set its distance from the two edges of the core layer to 0.04 meters. Click the Linear Pattern tool. Abaqus prompts you to select the entities to pattern. Select the rectangle. In the Linear Pattern dialog box, we can control how the pattern replicates in the vertical and horizontal directions. We need 6 columns and 1 row. Note that the spacing for the pattern in the horizontal direction is not just the thickness of the wall between the cells, but the distance from the left edge of a cell to the left edge of the next cell. So it's the cell width of 0.087 plus the wall thickness of 0.04, which gives us 0.127. The preview allows us to see the pattern update in real time. Click Done. As you can see, using a pattern accomplished the same goal as drawing the cells one by one, and it was a lot quicker. Create the bottom layer in the same manner as the top layer. Create the material AISI 1005 steel. Give it a mass density of 7,800 kilograms per meter cubed. For its elastic properties, set the Young's modulus to 200 gigapascals and the Poisson's ratio to 0.29. Create a solid homogeneous section called top layer section. Assign it the steel material. Similarly, create core layer section and bottom layer section. Since we're assigning the same material to each section, we might as well have just created one section in this demonstration. However, quite often with sandwich structures, you use different materials for the different layers. If you later decide to experiment with different materials as part of your analysis, it will be easier to assign different materials to each layer since they're already associated with separate sections. Assign the sections to their corresponding parts. It's time for assembling. Create a dependent instance of the top layer. Then create an instance of the core layer. By default, Abaqus positions instances in the assembly at the same coordinates as the local coordinates of the part. Since both our parts were created at the origin, they overlap each other in the assembly. Hence check Auto Offset from other instances, and Abaqus will automatically move the core instance to a suitable location. Let's create assembly constraints for these two part instances using the Create Constraint Face-to-Face tool. It might be hidden behind the Create Constraint Parallel Face tool. Abaqus prompts you to select the planar face or datum plane of the instance that will be moved. Select the bottom face of the top layer instance. Abaqus then prompts you to select the planar face or datum plane of the instance that will remain where it is. Click the top face of the core layer instance. Abaqus will display arrows on both faces. It will inform you that the instances will be constrained in such a way that the arrows point in the same direction, and will give you the option to flip it. Since the arrows for the correct faces are not already pointing in the same direction, we click Flip. Now that they point in the same direction, we can click OK. Set the distance between the two faces to 0 so that they will be touching once placed over one another. Use face-to-face constraints 2 more times to place the top layer instance on top of the core layer instance. Repeat the process for the bottom layer. Let's create sets for 2 nodes where we wish to obtain displacement history output. In the assembly container, double-click Sets. Name the set Displacement Point 1. Abaqus prompts you to select the geometry for the set. We would like to select a point on the inside of the core cell closest to the free end. However, we cannot select it as it is hidden by the bottom layer and the core layer itself. To make it visible, we shall use the Display Group toolbar. Click the Remove Selected tool in the toolbar. For the entities to remove, use the combo box to set it to instances. Click on the bottom layer instance to remove it. You can now select the node for the set. click Replace All to make the bottom layer visible again. Similarly, create another set for the corner of the bottom layer instance. We need to create a step for the analysis. We call it Apply Load and set it to type Static General. Turn on MLGeom for nonlinear geometry.